A random variable is a quantitative variable whose value depends on chance. Because the number of siblings varies from students to student, we gonna call it x. It's a variable. If we choose to select a student at random, then the number will become a random variable. It means a variable whose value depends on chance, namely the student being selected. So x will be called a random variable. If the random variable involves a count of something, then we call that random variable a discrete random variable. Capital X will be used for the event. The event of two siblings equal to 2 will be X, capital X equal to 2. The probability that the event X is equal to 2 will be P of capital X equal to 2. And it's read the probability that capital X is equal to 2. Here's an example of a probability distribution. The probability distribution of a random variable gives its possible values and their probabilities. Now, this is defined as the number of games played in a randomly selected World Series. Now, X is the number of games, and P of X is the probability of any of those lowercase x's. So it's P of capital X equal to 4 will be 18.5% or 0.185. Probability distributions can be organized into tables and histogram form. Probability distributions and histogram. We need to determine the probability distribution of the random variable x, and x denote the number of siblings of a randomly selected student. So P of x equal to 0 will be its frequency f, which is 8, divided by 40, which is the total frequency. So P of x equal to 0 will be equal to 0.200, which is 20%. P of x, another example, P of x, probability of x equal to 1 will be equal to its frequency, 17, divided by the total frequency, which is 40. So P of x equal to 1 will be equal to 0.4250, which is 42.5%. Similarly, P of x equal to 2 is equal to 27.5%. P of x equal to 3, 7.5%. P of x equal to 4, 2.5%. And the total, well, the total is just 1%. And this is the picture of the histogram. Feel free to stop the tape and look at it. If x describe the crew size of a randomly selected shuttle mission, then what are the possible values of x? So as the random variable, x can be 2, 3, 4, 5, 6, 7, and 8. The event that the shuttle obtained as a crew size of 7 will be x equal to 7, and the probability that x is equal to 4 will be 2, the frequency, divided by, well, let's just calculate the number, the total number of frequency, which is 4 plus 2 plus 36 plus 18 plus 33 plus 2. So the sample space is 96. So P of x equal to 4 is 2 over 96, which is approximately 0.021. 2.1%. Now, we need to obtain the probability distribution of x. And for the probability distribution for x, let's just do the total frequency, which is the sample space, 96. And then we have to calculate P of each value of the random variable separately. So P of 4 and P of 8 are equal, 2 over 96 or 2.1%. P of 2 is 4.2%. P of 3, 1 over 96, 0.1%, and so on and so forth. And for E, here's a picture of the histogram. Crew size is the horizontal axis, probability is the vertical axis.